Hey guys, I'm going to start going over a bunch of different valves, different control valves, check valves, stuff like that. Um, I'm definitely going to be missing some things. I'm not going to get right into the nitty gritty and start talking about packing glands, packing nuts, and completely dismantling things and explaining all their intricate bits and pieces. I just kind of want to point out the big key points to every valve and just kind of show you what they all look like. I know not everyone has had the opportunity to kind of see what a valve looks like on the inside. So this is kind of meant for more like guys who are in their first year of the apprenticeship and they're just kind of want a little bit of additional information just so they kind of know what someone's talking about when someone says, hey, go get me that ball valve, go get me that butterfly valve, so on and so forth. So I'm going to get right into it, and we're going to just start with butterfly valves. I find the best way to do this is just pros and cons. So one of the biggest pros is they are indicating. There's a flag on the butterfly valve right here. The flag basically mimics the orientation of the actual disc. So when the flag is like this, right, in the vertical position, that means also the disc is in the same orientation. The flag also points, if I pull the flag off, there's actually a little point right there that says open. And when the flag turns, it will turn and say shut. And just to prove it to you, I will start to close that valve. And as I close it, that flag is now pointing shut. Now I know that the disc on the inside is also going to be in this orientation perpendicular to the direction of the pipe. And now I know that the valve is actually closed. So that's a big pro. Another pro is they're light. They're typically light. I'll put it that way. When I say light, I just mean in comparison to like OS&Y valves and stuff like that. Obviously, the bigger the valve, the heavier it's going to get. So light, manageable. It was more just a relative term in comparison to other valves out there that are there. So joint connection methods, flanged groove. This one is a grooved. A flanged one is typically called a wafer butterfly. The takeoff of a wafer is much thinner, and you will typically require red rubber gaskets on each side. And if you are installing it, like say for example, from flange to groove, you'd put like a split flange or a uniflange or whatever. You also need a stainless steel ring to be put in between, and then the red rubber on your flange side. You don't want to have rubber to rubber, you're gonna get leaks. So you gotta have rubber, metal, rubber. That's how that works. So if you've just got a flange, like a wafer butterfly, and then on the other flange is actually just a straight steel flange, like just like this, like one of these kinds of flanges, then you simply just need one red rubber gasket. One of these guys right here. And it's that simple, right? Just whip that in between. Bob's your uncle. Maintenance. By pro on maintenance, it's basically just the fact that there really isn't much to do to maintain them. Annually, you have to fully close and open them as per NFPA 25. So as you're doing your inspections, you are just going to fully exercise that valve into the full range of motions, right? Give it a full close, give it a full open. And that's it. That's your maintenance. You don't have to grease them. There's no grease nipples. There's nothing else to it. Another pro for these, methods of supervision. So this one I kind of put in the pro category, only because there's one valve out there, maybe two, that are a little bit harder to supervise. So this is a Victaulic 705 butterfly valve. So these are pre-wired for supervision. So you actually just take their wires. They actually tell you, if you just actually read right on there, they will tell you exactly what each wire is for. If I can kind of catch the light there, right? So it will tell you what wires that you can use. So if you want to use like other accessories for relays or something like that, you can certainly do that. So all you do is you just end up putting a little utility box on it, and then your wiring for your fire alarm goes right into the utility box, and you just connect them together. Let's see, some of the cons is service. If I ever have a valve that fails, like that disc, I've got it shut and it's still passing, there's really not much you can do with these valves. If there's anything wrong with the body and the disc, at that point you basically have to change them out. I'm sure Victaulic might argue otherwise. They probably have like some kits that you can do and replace stuff, but unfortunately, like it's probably not worth your time. It's not really worth the risk in like ordering a repair kit and it might not work for whatever reason. The only thing I will say is you can actually take off the body from the housing right here. So there's two bolts just on the back. So if you actually just know the gear is your problem, like the gear mechanism on the inside of this, then you can actually just swap this out. Another neat thing about this, I know for sure for Victaulic, if you wanted to switch it, say for example this this valve was installed on a test header, someone ordered a 705 normally open control valve, and then they installed it on their test header, and then someone said, oh crap, it's got to be a 707. 707 means it's wired, supervised, normally closed. It's a normally closed valve. So if that ever happens, you can actually just take the top off, just put a 707 housing on there, and you're good to go. It is internally wired, it is internally supervised as a normally closed valve in that sense. So that's that for supervision and service. One of the downsides about these are hydraulics. So unlike an OS&Y, which we're going to get into, unlike an OS&Y, there is a disc in here that impedes the flow. Kind of just like anything else in sprinklers. We're always worried about hydraulics. We always want to try and give the best calcs that we can. As water flows through this valve, water kind of needs to fork and cut in between that disc, right? So it does create a little bit of a flow obstruction for these types of valves. So those of you that have installed fire pumps and stuff like that, there are rules for installing butterfly valves on the suction side of a fire pump. I believe it's no less than 50 feet from the suction flange or something like that. Could be wrong, but I'm pretty sure that's right. And that's all because of the hydraulics that impede the flow of water on here. It'll cause cavitation on your pump, right? So the reason I put some blue for a con for supply and discharge ports is it's not always true. This one does not have any ports on it, so it doesn't matter which way you really install it. There's supply side, discharge side, it doesn't matter. You can put it one way or the other. Some valves, especially you'll start to see them on like total packs and pre-action cabinets, they will actually have a port built in. So when you do have ports built in, you obviously need to make sure you're installing that port on the correct side. So at that point in time, orientation does make a difference. So when it comes to pre-action cabinets, that port that's on the supply side of the butterfly valve, on the supply side of the clapper, or sorry, of the disc of the butterfly valve, that port must be on the supply side because it feeds the priming line to your pre-action and total cabinet, so total pack cabinet. So ports do make a difference. Sometimes they have them. The reason I put in blue is just because typically you don't see it, and on a wafer you won't see ports on a wafer butterfly. They're just too thin. There's nowhere for them to stick a port for that. And orientation, I put that one in blue. Orientation and or axes of installation. So the reason I put the orientation in blue is because you can install them in any direction, typically, as you can see. However, there are pros and cons to each. You never really want to install these upside down. If you ever get sediment, mick, dirt, rust, whatever, debris, and it sits inside that, right where the stem enters into the valve, there is a seal in there, but you don't want all that sediment to be in the one spot that really makes contact with the separation of water to the housing of your valve. So upside down is frowned upon, I suppose you can say. So, and then when I went into axes, the reason I say that is because you do kind of want to keep in mind, think of water properties and the way it flows. So if I were to kind of draw this out, if I've got a 90 kind of coming up like this, like that, water picks up velocity. It's at its highest velocity on the exterior, just kind of like, right, as it takes that bend, this will be the lowest velocity coming around the short radius, and the long radius, it will pick up the most velocity on that. Kind of like when you have a bucket full of water and you can spin it around and you're not dropping any water. It's centrifugal force, right? Kind of spins its way around there. So that being said, when you are installing the valve on a bend like this, actually, I believe installation, they actually prefer you install the valve here if water supply goes this way. So we're going to say direction of flow. I should have mentioned that. Water flow goes in this direction through that 90. If you were to install the valve over here, what you would actually want to do because water is going to flow this way, you actually don't want to install, so let's pretend there's pipe coming up in here and into my valve. You do not actually want to install it this way, right? Because water is going to hit that top side. It's going to kind of chatter along the top of your disc. So if you've got the ability to, and you're installing this, here's my 90 coming up, you actually want to install this valve off the top. And that way, as water comes in, so let's kind of just take this. If here's my 90, let's spin it this way. You want water to come in and just get knifed. It just splits evenly, kind of this way. That will basically increase the longevity of your valve. It's just kind of small things like that make a difference. However, it's not mandatory. You don't have to. So there are websites online where you can sort of check and learn about kind of properties of water and better orientations to install butterfly valves. And if you get a chance, definitely I'd recommend just checking it out, just so it's just peace of mind. It makes you look a little bit more professional when you understand what you're doing when you're installing these things. So I am actually going to show you what the insides of this looks like, just because I have one. I'm going to take the flag off and take that faceplate off, and it is very simple. So this valve is open, right? That valve is currently open. And as I close it, there's a micro switch right here. So as I close it, that block is going to drop down. You're going to hear a click. There you go. A little orange micro switch is now exposed. So now we've changed the switch's states. So as per NFPA 25, you have to have a supervisory signal activate within 2 revolutions, 2 turns of the valve, or 1/5 of the full scale of the valve, right? So in this case, this is a normally open valve. So this is its normal state. This is how 99% of our valves are installed in sprinklers. It's always open. And basically, as I start to turn it, I got my little blue tape here on the side. Just after, call it 1 1/4 turns, that's switch activated. We now have a supervisory signal, right? And the reason that code is in place is basically in the event that you don't want it to go the opposite way. So if, for example, that signal came in 90% of the way, if that signal came in right around here, well, look how closed my valve is. My valve is 90% shut. So I want to know the moment someone starts playing around with my valve, if someone bumps it or someone starts to change its state, I want to know if someone accidentally brushed against that valve and close it a little bit. And it's still okay. But then another guy came by, brushed it. Ooh, right there. They've changed my switch's state. I now have a supervisory signal, but my valve is still 90% open for the most part. I'm picking that number out of the top of my head for the 90%. And I guess since I brought one here, just to prove it to you, I do have my Mita. I just took these 2 wires. We'll just wrap it around. That's like this. Whoop. Not working as well as I hoped. I will just put that on there like this. I'm just going to go to continuity. And so my valve's open. I'm going to start closing it. And there we go. My supervisory signal is now in. So it's as simple as that. Now, I'm going to just tell you one last thing about these Victaulic valves. So I just mentioned how this is a 705. This is normally open valve. I just quickly talked about test headers and how that's practically the only valve other than like an alarm test valve that you wouldn't have a monitored alarm test valve. So the test header valve is basically the only other valve that you'll order or see on site that is normally closed, and the only time you open it is annually when you're doing your pump flow test. In which case, for Victaulic, that would be a 707. So I'm going to tell you a little secret, but in order for Victaulic to make this valve a 707, so as you can see, as I'm going to close this valve all the way, so now that valve is closed, right? So if I saw this valve installed on a test header, I would actually fail it on my inspection, because I can start opening this valve. They can actually wire this up the right way. So they can actually use a different set of wires and clear the supervisory signal. However, when I start to open this test header valve, I'm not getting a signal. I'm still not getting a signal. I am still not getting a signal. My valve is already way open. My pump is turned on. Still not getting a signal. Still not getting a signal. Bam. Now that this valve is right here, now I'm getting that supervisory signal. And my valve is already 90% open at this point. So that is why this is the wrong type of valve to install on a test header. But what Victaulic did, they're very smart. They made their manufacturing costs very cheap. All they do is actually, they just take these two screws out, they just flip that micro switch block onto this side, and now that micro switch is pushing up against the block here. And it does the exact same thing. It's a normally closed valve. So very smart on their part. The only thing they have to now do is they create the same valve, they create the same micro switch, everything's the exact same, this plate's the exact same. The only thing they have to pay for is this little plate right here on this side. They take these two screws out, they print that this is a 707, change the figure, whatever date, blah, blah, blah. But that's all it is. So really smart for them. You didn't hear that from me that you can do that. So that's off the record. But just saying, you cannot actually do this in the field, technically speaking. Once you start playing around with those gears, you are changing the listing of the valve. So you cannot do that. I'm just saying, that's all there really is to it. So yeah, that micro switch is off you go. All right, so that covers butterfly valves for the most part. We're going to get into the next one. All right.